Okay, now we're going to change the length of the water column a little bit. It's in a bad place right here. It's on top of the, or underneath the tape. But the main thing is we want as long, I said water column, the air column. We want as long an air column as possible. So what I'm going to do is I'm going to remove the cap from this end. And I'm going to lower the bottle a little bit. Not so much that water is going to start siphoning in, but enough that I get a fairly long water column. I'm going to have to hold the bottle here with something. That's not a good thing to do. Didn't think that one through, did I? Okay. 'Cause I'm going to need two hands to get this cap back on up here. Well, this is getting to be a pain. Let's see what we can do. We've got a fairly long column. And I'll hold the bottle up by this tube. Probably can't see what I'm doing, but I'm just trying to get the cap back on the bottle. Okay, now I've got a longer air column, so that when the bottle's sitting here, I can straighten this out and read where the air column is. Okay? Now I'm going to get my source of hot water again. And that water is about 75 degrees Celsius. This time I'm going to set the water right here. And I'm going to dip it out with a styrofoam cup. Now, the tube goes up a distance of 1 meter. We can watch what happens to the pressure as the water climbs the tube. Okay, what's happening? Is the pressure changing? Yeah, I see the pressure gauge moving. Okay, the water is climbing. It's up about, probably 80 centimeters and still going. Now remember that when it gets up to the very top, and you're not going to be able to see that, but when it gets up to the very top, we want to read the pressure gauge and we want to read the temperature in the bottle with the thermometer that's in the bottle. Now it's pretty well stopped at about 90 centimeters. I'm going to add another cup, and it's up a little further. It's going up slowly. Another cup, and there it goes again. Okay, let's add some more water. Another cup. And we see, of course, that the pressure is certainly changing here. And another cup. It's just about up at 1 meter. Still going up. Another cup. And another. And now it's starting to overflow. And I don't want it to do that, so I'm going to stop it. But at the point when it just barely reaches the top, we want to read the pressure gauge and the temperature. Now as the water recedes back down the tube, you'll be able to see what's happening to the pressure gauge. Okay, in a minute the water will be at a level where you can see it coming down the tube. And we can certainly see that the pressure gauge is changing its reading. Okay, so the water is right about here where my thumb is, coming down, and shortly you'll be able to see it slowly descending. It's about here. She's got another inch to go. And there you see the water slowly descending the tube as the pressure lowers. Now we want to get this tube straight, and of course we want to measure where the top of the tube is, so we need data to get the length of the air column at every position. But we can see the system returning to its equilibrium position with the room. Now the goal of this experiment is going to be to determine how much water we can actually pump out of the system by filling the crock pot all the way to the same temperature, bringing the system to the same temperature every time. See how much water we can actually get to that height for various heights, for 50 centimeters, 70 centimeters, 90 centimeters, and so forth. Again, we use water between 60 and 80 Celsius, and we adjust our heights to see how much water we get at the different heights.